Okay, so like I mentioned last day, or as you learned last day, I suppose, you can add and subtract functions, and when you do, you combine their characteristics or compare their characteristics, right, based on the context of what's happening in your problem. And you can do a similar thing with products and quotients of functions. Okay, you can use two functions and either multiply or divide them to create a new function that shows maybe some different behavior about what's happening in the problem. Okay, so we're going to start off today with an example about hockey. You guys heard the song "Me Like Hockey"?
No.
No, you've never heard it? Man, go watch it on YouTube. It is inspirational.
I don't like hockey though.
You can leave.
Just keep those comments to yourself. The door's over there.
Okay. All right. So let's say that you had a hockey team manager. Let's call him Tim. Okay. Tim owns a hockey team and he wants to boost fan support at his games. Okay. He wants more people to come and he wants them to be more excited and more enthusiastic. Excited. We'll just say excited. Enthusiastic. Thank you. At the hockey games. So one of the things he decides to do is he decides to drop the ticket price, okay, in relation to whatever game number it is, okay. So he wants more and more people to come as the game numbers go on. So game number 1, he'll drop it by 10 cents. Game number 2, drops it by 20 cents, right, and so on. Originally, ticket prices are $10, which is really cheap for a hockey game, but they get cheaper as time goes on. Okay. To further increase fan support, he decides to randomly give away noisemakers. You guys know those thunder sticks, really annoying things, and the blowhorns and.
That Fraser always uses.
Yeah, sure. Okay. Different paraphernalia used for the fans to go crazy and wild and make lots of noise. Right? And the number of noisemakers randomly given away can be modeled with this function, right? Where less and less noisemakers are being given as the game number increases. Okay? The community fan base is small, but the owner does notice that since the incentives were put into place, cheaper ticket prices and more noisemakers, the attendance has started to increase. And you can kind of get a sense of that here with this model. Attendance A goes up based on the game number, right? So what we're going to do is we're going to determine a new function, R, and try to figure out what it means. To create that function, we're going to do this operation here, T dot A of G. What do you think we're going to do with T and A? Multiply, right? That's the product of those two functions. Okay, so whenever you see that dot, that really just means T of G times A of G. You're just multiplying those two functions together. Okay? So T of G was 10 minus 0.1 G. And A of G was 8 plus 0.2 G. Okay? And we're calling that new function R. And just doing a little bit of foiling and simplifying, that would give us, let's see, 80 plus 2G minus 0.8G plus 0.02G squared. This should be minus. How's that look now? That's positive. That's positive, that's negative, that's negative. Okay, yeah, we're good. And then simplifying, we get negative 0.02 G squared plus 1.2 G plus 80. Okay, and that's R of G. What do you think that function, that new function represents? Revenue, right? You took the ticket price, T, multiplied it by the number of people, the attendance, right? That would definitely tell you revenue at a particular game. Okay? And that will change based on how the game number increases or decreases, right? Because the ticket sales, or the price of the ticket is going to be different depending on what game number it is. So the revenue will be a little bit different as well. Okay, so this represents revenue. So on your calculator, we're going to graph it and interpret its meaning. Do you think there always will be an increase in revenue as the games go on? As the season progresses, tickets become cheaper, attendance is going up. Will they continue making more and more and more revenue? No, why?
Because parabola.
Because it's a okay, yes, because it's a parabola. But think about the problem though.
There's only so many seats.
There's only so many seats, okay.
And the price is going to go down so much that they won't be able to cover costs.
Yeah, right? You knock the ticket price down too much, and who cares if you sell a lot more tickets, you don't make as much money, revenue suffers, right? So let's graph that and see what happens. Okay, so our function was negative 0.02x squared plus 1.2g plus 80. And a window setting, let's x max, I don't know, let's try 50 games. And y max, revenue, 100, maybe? The y-intercept is 80, so maybe 200. Let's try that. Oh, maybe you were right. I'm going to make the x max go out a little bit more. Hockey's got 82 seasons, right?
Yes.
Or seasons, games. How does that look? That's a little bit better. Okay, so what is this saying? That's not a very good idea to do what he's doing. He'll start making money, right? But what game number does he start losing money? Yeah, that's the maximum point right there, right? So second trace 4. Come on, there we go.
30 games.
Find the maximum. Is it 30? Yeah, 30 games. Okay, they make a maximum of 98. That's probably thousands, $98,000, right? And after that, they start losing money. Okay, for C, we're going to create another algebraic model. This time we're going to label it as P. And we're going to create it by taking the functions n and a and dividing them. That's what this notation right here means. N over a means the function n, which was this guy, divided by the function a, which is this guy. And let's see what happens when we do that. So n was 2 minus 0.05g, and a was 8 plus 0.2g. And there's not really much simplification that we can do from here. So we'll just leave it like that. But think about what this would mean, right? You're taking n, the number of noisemakers handed out of the game, and dividing it by a, the number of people that came. Remember that the noisemakers are handed out randomly, so it's not necessarily the number of noisemakers per person, but more so the probability that you would get a noisemaker after walking into a certain game number, right? So that's useful for this next problem, which asks what the probability is of receiving a noisemaker if a fan attended game number 4. So to figure that out, all we have to do is put in 4 for G and then evaluate the value of P. And that will tell you the probability that you could walk into the game and get a noisemaker from one of the people who give them away. Okay, so we're evaluating P of 4, so that'd be 2 minus 0.05 times 4 over 8 plus 0.2 times 4. So let's see what that works out to be. Comes out to approximately 0.2, which means that there's a 20% chance that on game 4 you could walk in and get one of those noisemakers, one of those thunder sticks, or one of those big bugle horns, or